Welcome back, everyone. So in this video, we will focus on DFU over Bluetooth Low Energy, also known as FOTA over Bluetooth Low Energy. Basically, in the previous 5 videos, we programmed the SoC, the SoC on our board using the onboard debugger available on the development kits, right? And that was using a USB wire. This method is basically suitable for the development phase of your project. However, for your actual product, this method of using an onboard debugger is not really feasible. And instead, you want to have a way to securely update your firmware wirelessly. And that's what we will be covering in this video. So we will show you how easy it is in nRF Connect SDK to add FOTA over Bluetooth Low Energy. In order to enable FOTA over Bluetooth Low Energy, we first need to have a bootloader, and we will use MCUboot here. The bootloader is responsible for booting and also verifying new images. To include the bootloader, we simply need to set a single K config symbol. And in addition to the bootloader, we need the mechanism to transmit and receive new images over Bluetooth Low Energy. So for the transmit part, we will use a mobile application, but for the receive part on the firmware side, we will use MCUmgr and enable its Bluetooth Low Energy transport. This is done all by a single K config. The bootloader is essentially another nRF Connect SDK application that is booted before the main image. As a result, this is referred to as a multi-image build because you have now 2 images, the bootloader image and also the main application image. So the question now is, how do we build, flash, partition these 2 images? One way to do it is the manual way, same as we did before in a previous video for the non-volatile memory. But luckily, there is an easier way to do it. So nRF Connect SDK comes with tools that automate this process for you and make it simple and straightforward. Specifically, I'm talking about here Sysbuild and the partition manager to enable or automate the multi-image build and the partitioning of your project. I also included here some extra resources related to this topic. So one of them is a webinar by my colleague Sigurd, really great webinar. And also there is lesson 8 in the nRF Connect SDK intermediate course, which dive into depth about this topic. With that, I think we're done with the slide. So let's move to VS Code and get this implemented in the code. All right, so I'm back in VS Code. Just an FYI, I did a cleanup commit, which is just renaming the project and deleted unused files from the original LBS sample. And now let's start with the adding FOTA over Bluetooth Low Energy. First thing I want to do is to basically tell it that I want now to include MCUboot, and that's done. I'm going to do it using Sysbuild. It's a single line. You tell it, get me MCUboot, and you can see the kconfig start with SB because that's kind of like signifies it's a kconfig for Sysbuild, and that will get you the image, right? And I'm gonna also use now the partition manager. It really simplifies the process when you have multi-image builds. And while we're here, I want to be the only one who is able to upload FOTAs to my device. So I'm going to sign it with my own private key. And you pass it using this kconfig symbol, this one here. If you don't have this line, you will basically use the default key that is in the SDK, which is accessible to everyone. So the key, the private key, should remain private at your kind of like development environment, so somewhere secured on your PC, right? So this is something to keep in mind. And now I want to be able to control the other image. So I know how to control my application kind of like configuration through these kconfig files, but how do I control the configurations or the overlays, so both hardware and software configurations for the MCUboot, which is the other image that we will include? Well, it's really simple with Sysbuild. You need to create a folder called Sysbuild, and then you need to create a file that matches the name of that kind of like image, which is, I know it's MCUboot. So I'm gonna now write a kconfig fragment for it. And what I need to do here is I would like to disable the serial. I want this to remain low power, so I'll disable the serial and logging for for MCUboot as well. Now, what else I need to do to get done with this FOTA over Bluetooth Low Energy? So we got the bootloader, which is responsible for booting and kind of like also the verification that this is actually a legit image from a legit source. But now we need a mechanism to receive it from the kind of like mobile device side. So the mobile device will use an application to send it, and then you need to have a service, same as we did before with the Bluetooth Low Energy kind of like services. We need to have a service to receive this. And that's where we're going to go back to the application, and we were using the PRJ release, and we're going to add this kconfig, right? Same as we discussed in the slide. So that's going to get me MCUmgr, and it's kind of like Bluetooth Low Energy transport. And if you check the nRF Connect for mobile, you'll see it actually create a service, that's SMP service, that's responsible for kind of like receiving new images. All right. So I'm almost done with the kind of like changes needed to add FOTA over Bluetooth Low Energy. But it's also a good idea to have versioning system in place when you do FOTA. So you know, kind of like if you're pushing a new kind of like update, you know that this is a new one, and you keep track of the versions. And also there are a lot of features in MCUboot. Again, I have limited time with these videos, so I'm just scratching the surface here. So you can also enable kind of like downgrade prevention, stuff like that. And this relies on the versions of the kind of like updates that you push. So you see this file called version. We never talked about it in the previous video, and initially is set to match the kind of like SDK version used with this application, which is at the time of this recording I was using 2.7.0, but it's actually meant for the kind of like MCUboot versioning. So here you pick the version for this kind of like implementation. So I'll give it a version. So this is like a really rough prototyping, so I'll give it 0.1.0, and you can also have a version tweak and extra version here. So again, this file is meant to do version control on your kind of like FOTA images. So I've done that, and that's basically it. That's all the changes I need to do to kind of like add FOTA over Bluetooth Low Energy. So I added a line here, and there is the line for Sysbuild to include the bootloader, and this is kind of like best practice to use your own kind of like signing key, the private key. And now there are some changes I need to do to my application to make it work. Remember we did this pure DTS partitioning for the non-volatile storage. Well, all of this, I'll get rid of it and then basically rely on the partition manager and tell it like I'm using a memory. And now in my code, if you remember, here we said either use internal or external. Well, internal was small, so I'll just stick with the external. And then if I need to now define this partition using the partition manager, it's a different kind of like syntax. Same kind of like concepts, but the syntax a little bit differs. So you need to kind of like create a file in your application directory, and it needs to be called PM underscore kind of like static dot YAML, and then you tell it the name of your partition and the kind of like the address. And this region is actually defined by the partition manager. And by the way, I'm using kind of like the dynamic kind of like partition manager feature. When you're really close to production, it's better to kind of like define the whole kind of like partitions and kind of like fix them. That's kind of like really important to remember. So that's it. I think now we're ready to kind of like build the application. But we said now we're going to use Sysbuild, not the kind of like standard build. So I'll get rid of these two builds from before. Delete this and then delete this. And you can also see that the folders, the build folders have been deleted. And now select the development kit. Of course, we developed this so it can work with any development kit. But of course, you need to add the overlays in the board kind of like folder. And then I'm using the nRF 52840. the base configuration, remember here we're using the PRJ release. That's where we added the FOTA over, and that's the low power kind of like version. So make sure you select this, and here make sure you build for Sysbuild, because we're using this, we're using Sysbuild here, right? So, and then we're gonna call it, that's the release version. And then the GUI might change, but the concept here is that the GUI will pass to West that it's using Sysbuild. So if we check here, you can see here there should be, yeah, that's the sign where you know it's requesting Sysbuild. I'll speed up this part. You can see it started with MCUboot build. Speed up this part. All right, so the build is complete using Sysbuild, and what you notice now is like we have now two images. You have your main application image and MCUboot, and everything from generating like a single kind of like merged hex to signing the images, and all of that is managed by both Sysbuild and the partition manager. So it's really automated. And when it comes to the partitioning, if we open a new terminal and then we issue this command, this will show you the kind of like memory map, right? So you see now in the external flash we have the sensor data external, it's 8 megabyte, and then the partitioning done needed for MCUboot, it's primary kind of like slot, and the secondary slot. It's all managed by the partition manager. It's really nice to kind of like have this all automated and not needing to worry about it manually. But one thing to note that I need to reiterate here, like once you're close, once you're at the final stage of your kind of like development and you're close to production, it's it's really best practice to kind of like have everything statically defined here, all the partitions. Okay, with that, let me actually flash this 0.1.0 version of the firmware to my development kit. And then next, I will actually disconnect the USB cable and power my DK somehow by a battery, and send new images and new photos over Bluetooth Low Energy from my mobile device. So I'm assuming there is no longer a debugger chip on my kit. So let's do that. Okay, so I've flashed, the flashing is complete. And now I said I'll disconnect my DK from the USB port. So this is used to power the development kit and also provide a debugging kind of like interface, and also there's a USB to UART conversion. So I'm assuming now the hardware there is no onboard debugger. So I will basically send the firmware over there kind of like through Bluetooth Low Energy to the SOC. And I'll power it now using this battery, right? So there is no connection to my PC, right? This is just the PPK is just as acting as an ampere meter, and I just turn it on. It's working okay. Now let me open my let me mirror my phone and kind of like send a new image. But then what image are we going to send? So actually, before mirroring my phone, I'll go back to VS Code and make a new image with some noticeable changes, right? So for example, let's make some changes that the new image, when it's advertising, it's gonna use LED 4, and I'm gonna change the kind of like advertising kind of like interval, so I know that this is actually the new image. So let's go back to VS Code, and then I'll mirror the phone and send that image over to this development kit and basically do a photo over Bluetooth Low Energy. All right, so let's make this a new image with a noticeable change. So what I'll do, I'll just go to main.c, and there's this running state LED. I'll change it from LED 1 to LED 4, and the running kind of like state, kind of like interval for this LED, I'll change it from 1 second to, I don't know, 10 seconds. Just a value so I can notice it's different from the previous functionality. And then don't forget to actually update the version of this new kind of like firmware or image. So from 0.1.0 to 0.2.0, and then let's do a pristine build and wait for the build to finish, and while we're actually building one thing, so I'll kind of like speed up the building part, but while we're building, you notice that the connected device is no longer showing because I disconnected my DK. That's not kind of like a mandatory step. It's just for, I did that just for you kind of like to demo that it's actually through the wireless connection, not through the wire that I'm sending the new image. So I'll speed up this part, and then I'll show you which file you need to send to your mobile device so you can do the FOTA over Bluetooth Low Energy. Okay, so the build is complete, right? And then now if we check the build folder, so in my build folder, I named it build release, you'll find a file called dfu_application.zip. So that's the file that you will use for FOTA over Bluetooth Low Energy. And it contains the binary for the application, the new image, along with some metadata, so along with the manifest file that looks like this one. And here you'll find actually the version, 0.2 version that we set in the version. All right, so the next step, what I'll do, I'll send this file, the zip file, to my mobile device, and then I'll open my mobile device and open an application to do this FOTA over Bluetooth Low Energy. So let's do that. Okay, so I sent this file, the dfu_application.zip, to my mobile device, and I have mirrored my device. And also you can see on the screen that I have the development kit kind of like shown here. And it's kind of like, this is the existing kind of like image running. So let's scan and then connect to the sensor node device. And by the way, for doing FOTA over Bluetooth Low Energy, you have two options. Either that you use the device manager application dedicated for that, or you can use also the nRF Connect for mobile. So you can see here, nice thing about it will show you all the services. So in addition to the existing functionality, we have now the SMP service for doing. And we can see the LEDs here. LED 2 indicates connected, and LED 1 indicates actually running, kind of like the running state that is kind of like defined in the main.c. So if you click here and then you click on DFU, that's one way to do FOTA over Bluetooth Low Energy. So if you click on DFU and then select the DFU application file, done, test and confirm, and now the kind of like image transfer kind of like DFU process will happen in the background. So you can see the application is running as normally, and then once you're done, this will trigger a reset, and then the bootloader will notice that there's a new image in the secondary slot. It will validate it first. It will check, is this a legit image? Is it signed with the proper kind of like keys? If it yes, it will boot it up, and then you will see a message here indicated that the DFU has kind of like completed successfully. And if we notice now, the new image, so application has been sent successfully, and you can see now the LED 4 is representing the new kind of like running state for the device. So that's the new image kind of like transferred to the device wirelessly through Bluetooth Low Energy. So that was quite easy with the help of the nRF Connect SDK. So let's move back to the slides. All right, so that brings us to the end of this video. I hope you enjoyed it and found it useful. There are, of course, more resources and to read more to learn more about this. And of course, there is the Dev Academy courses to dive into depth into these topics, and there's our technical documentation. And if you feel if there are other topics that is worth kind of like covering in future videos, please let us know in the comments. And thank you very much for watching.